Good morning, or afternoon, or late evening, depending on when you're watching this. Welcome to the first video or the first lesson, that is, of Algebra 2. This is section 1.1. We're going to be talking about linear equations today, all right? So the first thing, before we get too far, we're going to go way back to the basics of what an algebraic sentence is, what a verbal sentence is, and then something that we do in math all the time, which is try and take the mathematics and understand it verbally and written out in words and connect those things together because they're kind of intimately linked. So let's get started. In algebraic and verbal sentences, for each of the value of the following, we're going to identify which are open sentences and which are equations, and that's something that we're going to come back to frequently throughout the course, is this idea of an equation and how that is different from an open sentence. So let's get started. Well, and number one here, we want to write an algebraic sentence to represent the verbal expression. Now, you've probably done a lot of these. You probably remember doing these in previous classes. We have this sentence here, 2 more than 4 times the cube of a number. And so whenever I see more than, I'm thinking plus 4 times the cube of a number. Okay, so 4 times, that's implying multiplication. Or maybe we should use a dot. Okay, so 4 times the cube of a number. That means the third power. So, and anytime we see a number, typically we're thinking a variable. So maybe we think x. Okay, so we have 2 more than. So that's 2 plus 4 times the cube. So 4 times the cube of a number. This is kind of, the cube of a number is, it's kind of one grouping there. So the cube of a number is x to the third power. And there's our first algebraic sentence. It is an open sentence because it does not have an equal sign in it. That's what makes it an open sentence. It's just an open mathematical statement, not connected to anything else with an equal sign. All right, you should try B on your own, see how you do, play the video, pause the video, try B, play the video, and see how it goes. Hopefully you paused and tried it. Now in this one we have the product of 6 and a number is 72. So the product of 6 and a number is, this is implying an equal sign. Okay, product implies multiplication. So we have 6 times a number. So we'll call it x, or you could use n or something like that, is equal to 72. Okay. All right, let's go the other way now. Let's switch to taking a verbal sentence, or making a verbal sentence to represent the mathematical expression that we have here. Okay, so in this one, we have x minus 5 over 12. And we don't usually write x minus 5 over 12 when we're trying to write the mathematical statement. What we have here is we have division. Okay, and division, we can say something like divides by 12. We could also use this word, the quotient, right? So what I've got here, and it's not the only right answer, but what I have here is the quotient of 5 less than a number Okay, so that's that piece on top. I've got, so I'm saying I'm about to have a quotient. What is that quotient of? Well, 5 less than a number, that's x minus 5, and 12. All right, so I have a quotient of 2 things, 5 less than a number, that's x minus 5, and 12. All right, go ahead and try the next one on your own. Hopefully you paused it and tried it. For this one, I have a sum. What do I have a sum of? Well, some number and 15. So I have the sum of a number and 15. Okay, so that's a few examples on algebraic sentences versus verbal sentences or written down. Okay, and now I want to move on to actually solving equations. So when we solve equations, we have all of these properties of algebra: reflexive, symmetric, transitive, and substitution. And all of these are useful. You learn them at some point, I'm sure. But what I want to do is not really linger on these. I put these in there for your reference, and I want to add one more word that the book doesn't have, but I think is really important, and that is, let's move the screen up here, and that is identity. okay? The identity comes in different forms for different operations. The identity is the number that basically doesn't change anything. So for addition, or what we call the additive identity, we have 0. 0 is the additive identity because if you add 0 to any number, you don't change the number. 7 plus 0 is 7, okay? And there's one for multiplication too, or as well, I guess. We call it the multiplicative. Try again. Okay, multiplicative identity, and that is 1. All right, the idea of identity will come up multiple times throughout the course. All right, so let's write your, what I'd like you to do on number 3 is pause the video and try and write your definition of solution below. Okay, so when you hear the word solution, I want you to write down what you think the word means. Okay, so go ahead and do that. All right, now I'm going to put my definition of solution, and I would write it like this: the value or values that make an equation true. Right? That's what we mean by solution. So let's come over here to this example number 4 here. You should obviously try this one on your own. You'll probably see that you've solved a lot of these in algebra and probably in geometry too. All right. We want to know 6 times what number is 24. Now you can think about this without doing any sort of algebraic operations. What do I multiply 6 by to give me 24? And you could probably get that the answer is 4. Okay, so x must equal 4. We can do this more systematically, what you might say algebraically, by asking ourselves, what can I do to 6 times x to make it so that all I have on the left is x? You think, okay, well, I have 6 times x. How do I undo multiplication? And what I'm really asking is, what's the inverse of multiplication? And so the inverse of multiplication is division. So I divide both sides by 6. I get 6 over 6, which is 1. So over here, I just have 1 times x is equal to 4, and we usually don't write the 1 out in front, so that's x equals 4, okay? And notice what we got here is the multiplicative identity. It's not a huge deal, but what I want you to know is that this is not some sort of magic trick. The 6 over 6, dividing by 6 does not make the 6 disappear. It just makes a fraction that simplifies to 1, which is the identity in multiplication. And so we end up with just x equals 4. All right, let's go over here to number 5. On number 5, we want to solve x over 5 equals 40. Again, we're asking what number divided by 5 gives us 40. You could probably figure out that it's going to be 200 without doing much math, but we can do it systematically as well. So we multiply both sides by 5. I get x equals 200. Over here, and I should have written this, maybe I will, I guess. 5 times 5 times x over 5, that results in a 5 over 5, which means we end up again with just 1. 5 over 5 is 1, all right? And so I get x equals 200. Again, we usually don't write the 1 out in front. All right, let's pull this stuff together. And again, we had division. To undo that, we used multiplication. All right, so coming back to number 6, some things around here. Okay, so solving this equation in number 6. Here we have a dreaded fraction. But don't worry, I think we can figure out how to do this. Again, you should try this, see how you do, and then play the video through to see if you got it right. I have 6 over 5 times x. What I really want on the left is 1, right? That's what we've been doing. We've been trying to get down to the identity times x. Because it's been multiplication. So to do that, I can do 2 things at once. And you'll notice that this is a combination of the problem up here, which was 6, multiplying by 6 here, and then dividing by 5 here to give me this 6 over 5. So it's a new problem, but it's going to build on these previous 2. And so what I'll do is I'm going to divide both sides by 6. That will give me a 6 over 6 here, which is perfect. That's what I want. And I'll multiply both sides by 5. And I can do that all in one step. Multiply both sides by 5. And then right here, I'll get 5 over 5. So if I do that, 5 over 6. On the left, I get 6 over 6. That's 1. 5 over 5, that's 1. So I end up with just x equals whatever this ends up being over here. All right. And this is probably a good refresher, good reminder. How do you multiply fractions? Well, we think of this as 12 over 1. And when we multiply when we multiply fractions, we multiply straight across the top, straight across the bottom. So 12 times 5. And then we're going to divide that by 1 times 6. 12 times 5 divided by 6 gives you 10. You can check me in the calculator if you want. I'm pretty sure that's what you get. All right. Now, number 7. Go ahead and try number 7 on your own. See how you do. It's going to build on the same sort of skills, and then I'll quickly give you the solution. So hopefully you paused, and here we go. The difference here in the previous one is that there's a typo in the notes. This should be negative 5 over 8x. Sorry, negative 5 over 8x. And to undo this negative sign, we need to multiply both sides by a negative 8 over 5 instead of just 8 over 5, because that negative will, a negative times a negative will give me a positive on the left. So we'll multiply this side by negative. In fact, we'll be even more careful. I'm not being careful enough, I suppose. Negative 1 times the left will give us 5/8 x equals negative 20. And now we just have to deal with the fraction. So I'll times both sides by 8 over 5. Shouldn't have written it like that. But this ends up being 1 over 1, so I get x equals negative 20 times 8 over 5 is your negative 32. All right, and that rounds out part 1 of solving linear equations. Okay, so hopefully that felt sort of familiar, sort of like review, and then you should be ready for part 2 of solving equations.